Hi everyone, welcome to this week's Spatial Spotlight with me, Helen McKenzie from Carto. I'm just going to double check quickly that you can see and hear me on LinkedIn because I'm recording from a different platform and there's a slight lag. I think we are okay, but if you have any problems, please message in the chat and I will try and sort them out. Yes, welcome. Today we're going to be talking about a topic that is very, very close to my heart. So I'm just going to share my screen and we will jump straight in. Hopefully you can see infinity now on my screen. So let's get going. So let me paint a picture for you. I imagine a lot of you know where this is. If not, this is Trafalgar Square in London. This is one of the most famous sites in all of London, one of the things that is most associated with London. But if you're a Londoner like me, there might be something that you think is even more synonymous with London. And that is Pret A Mangers. So if you don't have Pret A Mangers where you live, Pret A Mangers is a very excellent coffee chain. They do sandwiches, they do all sorts of food. And the joke is amongst Londoners that you can find Pret A Mangers on every corner of London. And here we have another one. So we have Pret A Mangers on two corners right next to each other. However, I've been living in London for about 5 years now, and I think this is overstated. And maybe there are some people in London who don't have access to Pret A Mangers as much as others. So today we're going to be undertaking a really serious bit of data journalism, and we're going to be working out where people have no access to Pret, where they are deprived of Pret A Mangers, very sadly. So the way that we're going to be doing this is we are going to be using a tool that Carto has called commercial hotspots, which basically assesses where there are significantly higher values of a range of variables to work out where there are hotspots. But we're kind of doing the opposite of that. We're working out where there's hotspots in a lack of something. So let's get started. Let's see where to start. I've got so many tabs open, so many things to show you today. Oh, spoiler. Okay, so first of all, we're going to be looking at a few different data sets and a few different variables to be working out where our de-PRET-vation hotspots are. I'm really sorry for the pun. It came to me one day and now I refuse to go without it. So there's a few different things we need to know to conduct this analysis. First of all, we need to know where our Pret A Mangers are. Very important. The way we have done this is we've taken data from one of our data partners called SafeGraph. Shout out if anyone from SafeGraph is on the call. They have a data set called Places, which is a really, really comprehensive data set of business locations and other points of interest across the UK. So that's what you're looking at here. We have mapped out all of the Pret A Mangers locations across all of London. So you can see down here, this is where we just were in Trafalgar Square now. So first of all, we want our Pret locations. And next what we want to do is get some deprivation data in there, because it's all very well saying, what's the sort of density of Pret, where are all the Prets? But actually what matters more is where the people are and where they are deprived of Pret. So the first thing we want to do is look at population density. Now, if you work with GIS data in the UK, you're probably familiar with this sort of site. This is a look at population density in the UK using a geography called output areas. So output areas are a little bit like, I guess, census tracts in the US is the sort of similar geography in the US. It's a really, really small administrative geography that is used to map census data. So that's what we're looking at here. But you may notice that there's quite a lot of gaps in this data set. We've got all these little black areas here, and they aren't no data, which is what you might expect, because as we zoom in, you can see that these get filled. This is basically because this data set is so detailed and it's so heavy that it's really, really difficult for a system, even like Carto, which is our whole thing is big data and we connect to cloud data warehouses, so we're very good at working with huge data sets. But even a system like Carto does struggle with these larger data sets. So that not only means that, our maps look a little bit rubbish like this, but it also means that we have to store this data, which is really heavy, really large to store. And it also means that our analysis is a bit slower. So what we're going to do is convert this to a spatial index called H3, which is basically a grid that covers all of the world, but we're obviously just looking at London today. And it's a hexagonal grid. And what makes it really, really special is that every hexagon, every cell, is geolocated by a short reference string. So I think it's about 14 characters, and that reference string tells you where in the world that hexagon should be placed, which makes it really, really small to store. And so it's sort of the opposite to an output area like these, which are really, really long geometry descriptions of what geolocates them in the world. So they're really heavy. So this is just a much lighter way of doing this sort of analysis. It's also really helpful for something like hotspot analysis, which is what we're doing, because it's a regular grid. So every hexagon is roughly the same size, roughly the same shape, especially on a local level like this, which means the data is sort of pre-normalized. So you can do this type of statistical analysis without having to normalize the data necessarily. So the way that we would do that is we would run something called an enrichment function. Oh, spoilers again. Pretend you didn't see that. So the way that an enrichment function works are we have, in fact, I will show you exactly where you can access this in case you want to emulate this yourself. So just while I'm getting here, there is if you are following this analysis and you're thinking, God, I also really want to map where people are deprived of Pret A Mangers in London because it's really important analysis, then you can head over to carto.com and you can see here we've got a try for free, and you can get yourself set up with a free 2-week trial, and you can copy all of the steps that I'm doing today. But what I've done here is I've just come over to our documentation page, and I'm going to head down to our analytics toolbox. You can see we have the analytics toolbox for all of the different cloud data warehouses that we connect to. I'm working with Google BigQuery today, so I'm just going to head into here, go into SQL reference and find our data module. And these are all basically Carto-specific user-defined functions that you can use with Spatial SQL, but it's really we've made it really slimmed down Spatial SQL, so it's not too difficult to use. And you can use these inside your cloud data warehouse. So all of the processing happens in there, and which makes things much easier. You don't have to sort of extract your data and put it back in. The tool that we're using today is called Enrich Grid, which is basically where we will be taking data from a geometry dataset, which is our output area dataset, and we will be joining that to our H3 index. The way that works is it basically will take every one of our, let me just head back to map, every one of our input-output areas. That sentence didn't make sense at all. Every one of our output areas, there's 27,000 of them, work out the proportional area that intersects with every one of our 19,000 H3 cells, which you can see we've got listed down here at the bottom, and works out the proportional area that intersects and assigns the population variable to that H3 cell based on that proportion. So I've taken our Enrich Grid SQL here and loaded it into my BigQuery console. And you can see, even if you're not a SQL user, and I have to admit I'm not the most advanced SQL user in the world, but I find this fairly straightforward to do, because all you need to do in the function is say, what is the type of grid that we are using? We are using H3. Then we say, what is the H3 grid that we want to join our data to, which is this. Then we say, what is our input data set? So what's our population data, which is this table here. We say which variables we want to join, and we can do as many as we want. We say we want to know the total. We say an output table. And then I'm just going to call this V2 because I've already run this. And I'm just going to run this now. I have run this earlier, but this is normally super, super quick. So I just wanted to illustrate how fast these types of processes are. Hopefully I will not be struck by the curse of the live demo and it not be super quick. But yeah, here you can see 11 seconds. So just to clarify what that calculation just did, that aggregated data from 27,000 output areas to 20,000 H3 cells in 11 seconds, which is, if you come from a sort of desktop GIS background like I do, I've always been a big QGIS user, that's astounding. That's normally an overnight job on your local computer. But let's take a look at the results. So here we go. Here is our H3 grid with population density assigned to it. So we can see here, if you're familiar with the geography of London, this will probably be quite familiar to you. You can see we've got the sort of like hollowed out centre, which is very expensive. It's where all the offices are. And then you've got this sort of inner London higher as a population density, and then moving out to the suburbs. So that's one thing we want to consider in analysing our de-PRET-vation hotspots. I'll stop saying that after that, it sounds stupid. Another thing we want to consider is also working population. So Pret A Mangers are often located around places like stations or areas like, I don't know, Heathrow Airport, where there's loads and loads of workers, but not necessarily a high population. And I'll just switch this to 3D so you can take a look here. So this is working population in London, so essentially the number of workers in all of these cases, all of these locations. So you can see central London here, no surprises, very, very high working population density. We've also got this area down here, which is Canary Wharf, which is sort of the big financial centre. And then we also have some regional areas down here like Croydon, Sutton. I actually live in Sutton, so shout out Sutton. So these are the first two things we want to consider, which is population density and working population density. And then the final thing we want to be thinking about is the geography of the PRETs themselves. So there's two things that I want to consider in this analysis. So it's the distance to closest PRET, and also the number of PRETs that you have within a 10-minute walk of where you are living or working. So say you're working in central London and you come out of the office on your lunch break and you really want a chicken and avocado sandwich. How many PRETs do you have to choose from? It's a very important question. So the way that I'm going to calculate this, actually I've already calculated it because I'm terrified of live demos, is using Carto workflows. So I don't know if everyone on the call is a Carto user. If you're not, this is still quite a new tool actually, so you might not all be familiar, but Carto Workflows is basically a low-code visual tool for running sort of multi-step analysis. So rather than having to write sort of 20, 30 lines of SQL to do this sort of analysis, in fact it would probably be more, you can run it in a tool like this, which is fantastic if you don't like coding, if you don't know how to code, or just if you want something a little bit more visual to maybe be able to better communicate what it is that you're doing. So I'm just going to really quickly talk through this final bit of the data pre-processing that this does. So we have two input data sets here. First of all, we have our London H3 grid. So this is the data set that we just created, which has the population and the working population data attached to it already. So think of it as one I created earlier. And then we also have our PRETs from SafeGraph. Now, if for the eagle-eyed among you, maybe you'll see that there are 11,000 PRETs here in the UK. That is incorrect. This is actually something that's really helpful about SafeGraph's data is PRETs. Is not just PRETs, I'm just obsessed with them. Points of interest are generated per time period. So this is actually a lot of duplicates of different time periods, which is really helpful if you want to sort of see what's changing in businesses over time. So I've just added this group by module here to just group each of the Pret A Mangers by their GeoID, so we don't have all those different time frames in there. So you can see we've got 763 PRETs in all of the UK. I believe in London there's about 270. Great knowledge for a pub quiz, everyone. So this workflow is doing two main things. First of all, we're using ST distance here, or actually, getting ahead of myself. The first thing we're doing is converting our H3 spatial index to a central point for each cell. So we've got a point that we can work with for this analysis. So the two things we're calculating here, first of all, is minimum distance. So we're using this function here called ST distance, which basically does exactly that. It works out, let me just bring up the results. It works out how far the closest PRET is to each of these H3 centres. So that's very straightforward. The next one, which is a little bit more complicated, but not too much, is we're now going to work out how many Pret A Mangers exist within a 10-minute walk of each H3 cell. So it's going to take that H3 centre again, and we're going to create a 800-metre buffer around it, which is roughly a 10-minute walk. If you were doing this for something other than a webinar, and this is really like important analysis, you're making business decisions with this, you might want to do something like use an isoline, which creates a sort of more realistic walking catchment based on the actual walking network. So it won't do things like, say, people can jump across rivers or anything like that. But this is just for illustration, so I'm just using buffers. Then what we do is use a spatial join to join every single PRET to the buffer that they fall inside. And then finally, we do a group by here, where we basically count the number of GeoID is the GeoID of each PRET. So we count the number of PRETs that fall within each of our buffers, which you can see here. All of this is in ascending order. So these are all just one. And then finally, we join all of that together. What you can see here. So here we now have a H3 index, which has the total population, the total working population, the distance to the nearest Pret A Manger. So you can see here, that's 5.7 kilometers. What a nightmare for this H3 cell. And then we also have the count of number of Pret A Mangers that are within an 800-meter, 10-minute walk, sorry. But what I've actually added on here as well, and you can see this in the SQL, and you can see this final variable here is the count inverse, because what we want to do is invert the number of counts, because for something to be a hotspot, it would be somewhere that has a high population, a high working population, a high distance from the nearest Pret A Manger, but a low number of Pret A Mangers within that 10-minute walk. So we just need to inverse that to be able to run that. So now we have all of our data prepared in one neat H3 grid. We can run our hotspot analysis. So yet again, we're going to be using a little bit of Spatial SQL and using one of the Carto SQL functions. So you can see here we have our hotspot analysis. This tool is called commercial hotspots, but it doesn't necessarily have to be used for commercial hotspots. It's basically a tool that runs hotspot analysis, but with multiple variables, and they can be any variables you want. So let me just walk you again through this SQL. Again, it's really straightforward. I think this is one of the first. I joined Carto about 1.5 years ago, and this is one of the first SQL tools I used when I joined Carto, and my SQL was rusty at best at that time, and I found this very straightforward. So the first thing we do is we input our we say what is our H3 grid that we've just created. So we've called ours Pret input v2. And then we say, what do we want to output our results to? What's the name of the table? So we're calling it Pret hotspots. And then these two here are just saying what is the type of the grid that you're using and what is the variable column that you are using to store that grid ID in. And then we just need to say what the variables are that we're using. So population sum, working population sum, nearest distance to Pret, and the inverted count. And then these numbers here are really, really useful. So these are the weights. So you can see here we've got 0.2, 0.2, 0.3, 0.3. They have to add up to 1. And what we've done here is we've just said that for our totally fictional analysis, population sum and working population sum are a bit less important to us, so we're going to give them the smaller weight. And you can sort of change these as you want, as long as that adds up to 1. So for example, after COVID, there was a lot of talk about how, I feel like in the UK we're just obsessed with Pret. There was a lot of talk in the UK about how Pret was thinking of moving more to the suburbs and away from more sort of areas like the city and the West End where there's fewer people living, but there's a high workforce. They wanted to go to where there's more people living because of working from home patterns. So what you might want to do is reduce the weight of the working population or take it out altogether. And then finally, I promise, because I realise I'm nearly over time, I promise we're nearly at the end. This number 3 here is the neighbourhood size, so the number of H3 cells that are going to be incorporated into the analysis. And then finally, we have the p-value threshold. So here we've chosen 0.05, which means that we can be confident to 95% that the results that we generate are actually a hotspot. So I'm just actually going to go ahead and run this. I've actually run this already, but I think this doesn't take a super long time to run. Let's just give it a few seconds, and if it takes longer than I remember, then we can just head back over to the map and check out the results that I generated earlier. I think it was around 30 seconds. Okay, we can just come back and have a look at this when I finish showing you the results, because the results are kind of a bit more exciting than watching a countdown going off. So let's head over to the final map. And here we are. These are our de-PRET-vation hotspots. So you can see what I've done is this analysis generates a statistic called GI star, which or a combined GI star, because it's the combined hotspot statistic for all of the different variables. So the yellow areas here are where that value is highest, meaning the cluster is strongest. So you can see we've got a lot of areas in suburban London and outer London, in these sort of suburban centres, particularly East London, around sort of Romford and Dagenham, and also down here in South London and Sutton, where I live. Fantastic. Pret A Manger, if you're watching this, please may have a Pret. And also some of these sort of inner London areas where we know the population is high. We know we're going to have a lot of people working in these areas like Edgware as well, sort of important regional centres, but they don't have a Pret, and they're very far away from existing Prets. So if I were a data analyst working for Pret or a similar store, I might take this analysis and say, great, these are the kind of areas where if we're wanting to expand, we should think about expanding to these areas. There's also loads of other elements that you might want to take into this analysis. So things like who are my competitors and what's their sort of landscape looking like? Do we have, for example, loads of competitors in Romford already? Does that mean we don't really want to touch it? We might also want to look at the sort of demographics of the local population, so breaking it down into who are sort of target market. Are they people of a certain age, a certain gender, certain behaviours more likely to shop at Pret? For example, are they very sort of hipster people? Are they more likely to want to shop at independent coffee chains, or would they go to Pret? That sort of thing. So there's loads of ways that you could take this analysis even further. Let's just head back into BigQuery, and we can see that this analysis only took 1 minute and 1 second to run the commercial hotspots. So that is to run this quite sort of heavy process on around 20,000 H3 cells, but getting that level of insight and on that at this sort of local scale, at this detail, I think is really, really fantastic. And I think that is pretty much everything from me. If I can just stop sharing my screen so I can say bye. So thank you. Oh, I realise I'm a bit over time. I'm sorry about that. Thank you so much for coming along to the Spatial Spotlight. I hope you found it enjoyable. I hope you didn't suffer through my puns or love of coffee chains too much. But I hope it was interesting to you. If you have any questions, please do feel free to drop them in the chat and I will get back to you on them. And if you enjoyed this, we're running these sessions every week. So do please come back same time again next week for the next session. Or if you follow us on YouTube, at Carto HQ, I believe it is, then you can find all of our past events on there as well. So thank you so much for coming and have a great rest of your day.